the real number system, real numbers are a combination of rational numbers and irrational numbers. Rational numbers are numbers that can be written as fractions, such as -4. We can write that over 1, make it a fraction. 0.15, we can write that as 15 over 100. That is a fraction. Okay? So almost any number can be written as a fraction, so that's a rational number. There's a couple instances where they cannot be written as a fraction. Those are called irrational numbers. Pi, okay, pi is an example of one because 3.14159 that continues on. Okay, pi does not end, yet it does not have a pattern to it. It's completely random. So we cannot write that as a fraction. The square root of 5, okay, that is the same thing as pi where it does not end yet, it does not have a pattern, it does not repeat in a pattern. Okay, 0.2 repeating, can that be written as a fraction? If you remember when we talked about making decimals and fractions, anything that's a repeating decimal can be written over 9. Remember? Is this a fraction? Yes, so is 0.2 repeating a rational number? Yes, it is. Okay? Don't let repeating numbers, don't assume that a repeating number is an irrational number. Okay? Irrational numbers are numbers that don't repeat and don't end. Okay? Alright, write this down. You need to have this chart. You're going to use this chart later today. The sets of rational numbers and the irrational numbers together make up the set of real numbers. So rational numbers and irrational numbers are both considered real numbers. Okay? Rational numbers or any numbers can be written as fractions. Can whole numbers be written as fractions? Can integers be written as fractions? Can rational numbers be written as fractions? Yes, that is the definition of a rational number. Okay? Whole numbers, 0, 1, 2, 3. Integers are negative numbers and whole numbers. Rational numbers are anything that's left. Okay? Integers do not have decimals. Whole numbers do not have decimals. Okay? Irrational, pi, square root of 5, 0.04225. Just a number that continues on, that does not end, and does not repeat. Alright, write this down. We're going to answer them here in a second. Name all sets of the numbers to which each real number belongs. This is going to what some of your homework will look like. Okay, 21 over 7. Does that reduce to anything?
Yes.
What, Blaine?
3 over 1.
3 or 3 over 1. Okay, so what does 3 belong to? Someone raise your hand. Blaine? It is a whole number. What else does it belong to? Mackenzie?
Rational.
It is a rational number. Is there any others? Blaine?
Integer.
It is an integer. Okay. Negative 2.5. Someone raise your hand. Tell me what this is. Blaine?
Integer.
It's not an integer. Integers do not have decimals. Anyone else? Blaine?
It's a rational.
It is a rational number. Can this be written as a fraction?
Yes.
Yes. Hey, that's what you should ask yourself first. Can this be written as a fraction? If it's yes, then rational. All right. Emery, can 0.2 repeating be written as a fraction? Look on your chart. It's even on your chart.
Oh, yes.
It is, because 0.2 repeating is the same as 2/9, right? Anything that repeats, we can write it over 9 and make it repeat a decimal. Is this a fraction? So that means it's what, Emery? Rational. Bless you, Paul. Now, square root of 38. Paul?
It's a whole number.
No, it is not. Yes, Blaine.
Rational number.
It is not a rational number. It is irrational. Okay? If you don't know, alright, can I look it up? Can I say can I use a calculator and see what it comes out to?
Yeah.
Square root of 38 is 6.164414003 and on. Does that seem like it's got a pattern to it? Does it seem like it's going to end? So it's irrational. Cannot be written as a fraction. Alright, you need to write this. Okay? Now we're going to solve squared variables. A squared equals 36. So when we squared A, when we took A times A, we got 36. So what we do is we take the square root of both sides. Remember what you do one side, you do the other? Square root of A squared just makes that A. Alright? Blaine, what's the answer?
6.
Okay, 6 is one of the answers. There's 2 of them. Someone want to take a guess, see what the other answer is? Huh? What, Blaine?
Negative.
-6. Okay? Because what's 6 times 6, Blaine?
36.
What's -6 times -6?
36.
36. So, do I know exactly what A is, or could it be one of 2 options? One of 2 options. I could plug 6 in there. Would this be right if I plug 6 in there? To A?
Yeah.
Would -6 work if I plugged in for A? Yes. Alright, write this. 2n squared equals 170. Okay, we have 2 times n squared equals 170. 2 times n squared equals 170. So I need to get n squared by itself. Before I can square root both sides, n squared has to be by itself. So first thing I do is divide by 2. N squared equals 85. Then I take the square root of both sides. N equals plus or minus. Now I can go ahead and solve this out. I can find that it's 9.3 or 9.4, okay, something like that. Or I could just leave it as a square root of 85. Okay, because if you don't have a calculator available, do you need to figure out what it is, or can you just know that it's square root of 85?
Well, not what it is.
Okay, you don't need to know what it is. Okay, that's the whole point. Alright, that's why we're going to leave it as this. Alright, write this one. You go ahead and solve it on your own. Nikki, what's my first step? What did you do first? You divide by 3? Because it's 3 times d squared, we got to get d squared by itself. Which, Nikki, was 363 divided by 3? 121 equals d squared. What was the next step? Take the square root of what? Both sides? D equals what? Which what is the square root of 121? It is 11. Plus or minus 11. Okay? Because it could be positive 11 or it could be negative 11. Doesn't matter which. No, because either one makes us true, doesn't it? What's negative 11 times negative 11? Positive 121. What's positive 121 times 3? 363. Okay, we're just solving it. What's 11 times 11?
121.
What's 121 times 3?
363.
Here we go. So plus or minus works for both. Here's your assignment.